Hi, my name's Phil van der Mortel. I'm part of Intel's Edge sales team. Based up here in Seattle, I cover Microsoft's IoT business. Let's talk a little bit around Edge compute, hybrid or on-prem. Intel and Microsoft have a long history and exciting future ahead in this space. When the Edge and the cloud converge, brand new use cases can be created. Vision, AI, analytics all become possible by placing the compute on-prem, where the customer needs it. We're going to talk a little bit with David Armour shortly. What Microsoft and Intel have learned is that many customers have challenges engaging in those first steps to deliver the value of AI. How do customers get up and running within a day? How do customers get out of the box without the hassle and complexity around security, around POC, around the value of the data? We're going to now listen to David, who's going to walk us through exactly what Microsoft have been doing to enable this.
Hi, I'm Dave Armour. I'm a program manager on the Azure Stack team. I'm responsible for bringing Azure services to the Azure Stack platforms. And I'm also responsible for our manufacturing customers and the scenarios that they bring. One of the things a lot of my manufacturing customers tell me that they're interested in is video analytics and machine learning. They view this as a very disruptive technology that they want to know more about. If you think about it, traditional sensors like a thermometer can measure just temperature, and a pressure sensor can just measure pressure. But with a video camera, I can not only measure temperature, but I can measure shape, color, speed, distance, so many things. And because of this, customers want to do more with video analytics, yet they don't really know how to get started. So we zeroed in on that problem. How can somebody within a very short period of time, ideally even a day or maybe a couple of hours, without hiring a data scientist, do a proof of concept and show their manager what's possible with video analytics? So that's what we've done. So let me give you a view of this solution. First of all, this is running on an Azure Stack Edge device that I have in my own facility. As you can see, it's running on my local network. This is important because I can do a lot of video analytics, including the detection, without relying on that network connection, which I might not have within my facility. For my demo today, we're going to be inspecting my flashlight assembly area. This is a location that I've defined in the system. But you can imagine an area for auto assembly or any other type of assembly that I might want to do in a manufacturing process. Once I have that location, I want to define how my camera is looking at that location. So here I've already gone ahead and I've created an overhead camera for my flashlight assembly area. This camera is looking down on all of my parts. Now right now the system doesn't really know what these parts are because I need to teach the system what these parts are. One of the interesting things about manufacturing is that each manufacturer produces a set of parts that's kind of unique to them. They can't go out and buy somebody else's machine learning model, they have to make it themselves. And so this is why we zeroed in on making this whole part definition experience very simple. So let me show you what that experience looks like. I click over here on part, and I'm going to look at the flashlight shaft. Here I have a set of images that I've already taken, and I can add more images to that. Each time I add a new image into my repository, I increase the accuracy of the back-end model. So I'm going to take a number of these pictures. You can see I draw a rectangle around it that tells the system that this is a flashlight shaft and not a battery or an LED light. So after we've defined squares around all of the images, I'm going to save that and we will send that up to Azure, enter it into Custom Vision AI, which will generate a machine learning model for it. It will package that into a container, and that will come back to my Azure Stack Edge device. Now to the user, this all happens automatically. So when I go to part identification, you can see it starts to detect the parts that I care about. So when we look over here, it's putting a red square around the images as they show up in the camera feed, and it tells me the confidence level. So here it's getting about 80–90% level of confidence with the images that I provided. Now what I've done is I've set up an accuracy range to tell the system to capture images when its confidence is between 20 and 60%. And I've asked it to store 40 of those images. Now I can make that as large as I want. I've capped it at 40 so I don't fill up my hard drive with a bunch of images. The other thing I've done is I've told the system, hey, when you're 30% confidence, go ahead and draw that box. So you can see 96% of the time it's confident enough to draw that box around it. And it's identified many instances successfully. However, there's been a number of times where it saw something it wasn't quite so sure about. So let's have a look at what those unidentified items are. As you can see, it's done a really good job. It wasn't confident enough to say for sure that that was either a flashlight shaft or a battery. But what that gives me is an opportunity to look at these images, and if I agree with it, I can just simply go save and next. And every time I do this, it will be added to my model. And the next time I run this model, I'll have even higher accuracy rates in the detections. So I'm going to go through and label all of these. So you can see this is a very simple process for me to go through and identify these things. In fact, sometimes you can see they're blurry, and it already picked those up with a pretty high level of confidence. Sometimes if I wanted to be a little bit more accurate, maybe I want to draw that rectangle a little bit more precisely. And when I'm done, I'm going to go ahead and update the model like this. Now, in data science, this would be called retraining. But you can see we've avoided a lot of the jargon. What we're trying to do is make this whole proof of concept very approachable to someone who doesn't have a data science background. You don't see terms like classification or linear regression. Instead, we just focus on the task at hand, which is identifying the parts, teaching the system what these parts are. After I've done that, I can go back and continue with my part identification. With a retrained model, it will have higher confidence. So what we've shown you today is a solution for doing a proof of concept in your manufacturing facility. When you want to bring this to production, we have a number of partners that can work with you to deliver a solution with the confidence level that you would expect in your production lines and the ability to integrate the data coming off the system into other systems that you care about. Thank you very much for watching our presentation today.